Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And today we continue to explain pure mathematics 3, and we are in the very last example of in the very last topic, example 3. We are in topic number 8, numerical methods. And we're looking at example 3. I want to explain example 3, and it's talking about using the same axis, sketch the graph of y is equals to ln x and y is equals to 1 over x, and explain how your diagram shows that the function fx is equal to ln x minus 1 over x has only one root. We are expected to sketch the graph of y is equals to ln x and y is equals to 1 over x. And it goes without saying that the graph of y is equals to 1 over x is simply that way, and this is y and this is x. It goes without saying. We have to be very careful because ln1 is known to be 0. So the graph of ln x has to pass here. And of course, as x reduces, ln x becomes a bigger negative. There is no way ln anything can be a negative number, so it has an asymptote along the y-axis, and of course y is equals to ln x and y is equals to 1 over x. That is just like it. And of course, having plotted that, this is 1. Remember, you can have 2, 3 minus 1, and so on and so forth. That is obviously 0. We are told that to show, explain how your diagram shows that the function fx is equals to ln x minus 1 over x has only one root. Now you must realize that this function ln x minus 1 over x is just one of the same thing, and especially when we are talking about this graph and this graph, when fx is equals to 0, because we should solve all the function when they are equals to 0. When fx is equals to 0. Now, at that particular point, ln x, which is the function minus 1 over x, is the one which is supposed to be 0. And of course, when this is true, then ln x is equals to 1 over x. Of course, you can see these are two simultaneous equations. And when they are equal, we only go to the point. We only look for the point of intersection. Point of intersection. When they intersect, of course, this is the point we are talking about, and this is the point when and where fx itself is equals to 0. And the reason why fx is 0 at this particular point is because ln x is equals to 1 over x, and that is true. So the fact that they intersect at only one point of intersection, which is only 1, the point of intersection is only 1, which is only 1, meaning that fx is equals to ln x minus 1 over x has only one solution, has only one root, and that is just like it. Part B of the question, it's talking of, show that this root lies in the interval 1.7 and 1.8. Show that this root lies in the interval x 1.7, 1.8. You just have to show that this root lies in this particular interval. How do we show this? How do we show this? When we are talking about showing this, the root itself is greater than 1.7. So there is no way it can be 1.7. And the root itself is less than 1.8. There is no way it can be 1.8. And if it is between this particular interval, when we substitute fx with these limits, one of them should be negative, the other one should be positive, and that is it. And the change of sign is the one which one should tell us. So the change of sign should tell us now the root lies between the two boundaries. And therefore, we first talk about the function of 1.7. And this is going to be ln 1.7 minus 1 over 1.7. We are simply substituting. And we talk about ln 1.7 minus 1 over 1.7, and what this is going to give us? Negative 0.0576. Negative 0.0576. This is negative 0.0576. Moving forward, of course, it continues. And what about f? What about f 1.8 is equals to ln 1.8 minus 1 over 1.8, which is again going to give us ln 1.8 minus 1 over 1.8, and then we talk about 0.0322. 0.0322 is equal to 0.0322. Of course, continuing. Now it shows that the change of sign, which is very clear, the change of sign here, the change of sign, which is very clear here, the change of sign, which is very, very clear there, shows that the root is between the change of sign, in these two solutions proves that the root is between the two given limits of x. Of course, it's between the two given limits of x. And again, part C, let's talk about part C. Part C is asking, given that the root of fx is alpha, given that the root of fx is alpha, the root of fx is alpha, given that the root is alpha, show that alpha is 1.763, correct to 3 decimal places, and this is now the bone of contention. The reason when we talk about the root itself is now squeezed, it shrunk to a very, very small boundary, then we are saying that if we take 1.763, the root is this, correct to 3 decimal places. We must know what was happening before we got here. So we must tell what was happening on the left and what was happening on the right. And the limit we should take on the left is a number such that when we round it up to 3 decimal places, it will still give us 1.763. So let's take 1.7625. And on the right, 1.7634 or even 35. Let's just talk about 35. Though 35 will give us 764. But anyway, it's something just to show whether we are going to get change of sign when you use the two limits. And at the end of the day, it is now our duty to talk about the function of 1.7625. If you substitute this in the ln 1.7625 minus 1 over 1.7625, it's going to give us something. Let's just see. Ln 1.7625 minus 1 over 1.7625 is going to give us something to do with is equals to negative 6.426 times 10 raised to the power negative 4, which is rather 0.0006426. And what about the function of 1.7635? This is the same thing, and it's going to give you you have the same arrangement. Ln 1.7635 minus 1 over 1.7635, which is let's see, ln 1.7635 minus 1 over 1.7635, we get to see it's going to be 2.463, which is 2.463 times 10 raised to the power negative 4, which is 0.002463. Again, you can see this is a positive number and this is a negative number. And clearly, the change of sign, we have been able to show that the function of this is giving us a negative number, and the function of 1.7635 is giving us a positive number. And clearly, the change of sign tells us alpha is greater than or equals to, it's going to be, the change of sign is 1.7625 and less than 1.7635. We do not have, of course, there is no way alpha can be equals to this, because this one has already given us a negative number. And there is no way alpha can be equals to this. It's already given us a positive number. Alpha is the number that is going to be substituted in the function to give us 0. So we can simply say that correct to 3 decimal places, alpha is 1.763 to 3 decimal places. Of course, that shows everything, and we have been able to prove that. Okay.